Hello everyone, myself S.S. Arora, PGT Physics from Kendriya Vidyalaya Bad Mathura, and in this part 2 of the mechanical properties of solids, I shall try to explain you the modulus of elasticity. Firstly, the question is, what is modulus of elasticity? So in the Hooke's law, we have studied the modulus of elasticity is the ratio of stress to the strain. Now, if the type of the stress or the type of the strains are different, like for example, if you take a wire, hang it from the roof, apply some weight at the bottom, mg will be the weight, pi r square will be the cross sectional area, the stress will be the normal stress. Normal stress is that stress which acts normally, perpendicularly to the cross section. So here the normal stress results into the longitudinal strain. Longitudinal strain is the change in length per unit original length. This ratio of normal stress to the longitudinal strain is the Young's modulus. Young's modulus is the ratio of normal stress to the longitudinal strain. And now, what is bulk modulus? When the stress is normal, for example, if you take any body and that body is immersed into the water, from all sides there will be a normal force and there will be a normal stress, and it results into a pressure under the water. So that is the normal stress. But the change in the body will be the volumetric change. So the strain will be volumetric. So the volumetric strain is change in the volume, means the decrease in the volume delta V by V. This is the this is the bulk modulus. Bulk modulus is the ratio of normal stress to the volumetric strain. And the third type is the shear modulus. Modulus of rigidity. The modulus of rigidity is the ratio of tangential stress. Tangential stress, how do you apply tangential force? You apply a tangential force on anything, any surface, when you apply a tangential force, that results into tangential stress on the body. Suppose you take a book, very thick book, place it on the table, apply a force, that is the tangential stress, and the strain will be shearing strain, the change in the angular displacement. This results into the modulus of rigidity. All the modulus of rigidity has the same unit, Newton per meter square. That is the unit of stress. Strain has no unit. And all the modulus of rigidity has the same dimension, m, l minus 1, t minus 2. But there is another term which is compressibility. How much a thing can be compressed is the compressibility. Now the thing can be compressed more if its bulk modulus is smaller. If its bulk modulus is higher, thing can be compressed less. Compressibility of anything is the reciprocal of the bulk modulus. So you may need to find compressibility also. You may need to find the Young's modulus or the bulk modulus or modulus of rigidity. This type you can do it. Now one more thing to add in it is, solids are more elastic or liquids are more elastic or gases are more elastic. So solids are more elastic because they are highly resistant to the deforming forces, or they develop greater restoring forces in them. So therefore they are more elastic, they have high modulus of elasticity. So solids are more elastic. And even only solids have a modulus of rigidity. Solids have only rigidity, liquids have no rigidity, gases have no rigidity. Gases and liquids have zero modulus of rigidity, they are not rigid. And the Young's modulus is defined for the solids only. It is not defined for the liquids, because liquids cannot have a longitudinal strain, and the gases also. They cannot be drawn into wire. And steel is more elastic or rubber is more elastic? Then the answer is steel is more elastic, because steel has a higher modulus of elasticity, Young's modulus of elasticity. While rubber is an elastomer, rubber produces large amount of strain. If you stretch rubber, it produces large amount of strain for a small deforming force. So rubber is less elastic than steel. Thank you very much.